Toyota, renowned for crafting vehicles that are reliable, efficient, and at the forefront of innovation, continually satisfies its customers. This Japanese company has a history of being a trailblazer in the automotive industry, notably in the development of alternative methods for powering vehicles. It has recently achieved a significant milestone with the potential to redefine industry standards and challenge the growing popularity of electric cars. Let's delve into this groundbreaking innovation and its implications for the electric vehicle sector. Green Automotive Revolution. Toyota, in collaboration with the Chinese conglomerate GC, with Toyota as the principal investor, has quietly developed a groundbreaking technology that promises to alter the global perspective on electric vehicles. But what exactly is this innovation, and how might it impact the electric vehicle sector? Let's explore how Toyota's latest breakthrough could signal the end of the current era of electric cars. GC has achieved a remarkable feat in the automobile market by developing the world's first ammonia-powered engine. This engine utilizes ammonia, composed of one nitrogen atom and 3 hydrogen atoms, as fuel. Its main advantage lies in its carbon-free composition, eliminating carbon dioxide emissions, unlike traditional fuels such as oil and gas. This positions ammonia engines at the forefront of solutions to combat air pollution. Several strategies exist for optimizing the use of ammonia in engines. One approach involves decomposing ammonia into hydrogen and nitrogen, with the hydrogen then used to generate electricity in a fuel cell. The startup company Moj implemented this technique in a John Deere tractor, creating the world's first emission-free tractor powered by ammonia. Another method mixes ammonia with fuels like diesel, gasoline, or hydrogen to facilitate combustion. This technique aids in ignition and maintaining combustion. Main Energy Solution adopted this approach when it developed a 2-stroke maritime engine powered by ammonia. A third method uses ammonia as the primary fuel source, requiring sophisticated ignition technologies such as spark ignition, compression ignition, or homogeneous charge compression ignition. These technologies enhance engine performance and efficiency by optimizing combustion timing and pressure. Ammonia engines represent a promising innovation with the potential to revolutionize the electric vehicle sector. They offer a cleaner, more economical, and sustainable path to mobility, reducing dependence on fossil fuels and lowering emissions that contribute to global warming. Thus, ammonia engines could be a transformative milestone in the electric vehicle industry. Towards green innovation. GC now boasts an exceptional 2-liter, 4-cylinder engine capable of producing 161 horsepower while cutting carbon emissions by 90%. At a new technology event, the company shared the challenges faced, including increased combustion pressure and elevated nitrogen emissions. Ammonia, highly toxic and commonly used in fertilizers, emerges as an innovative solution. Despite being flammable, it is seen as a promising fuel for the future of transportation. Its energy density is half that of gasoline, at 3.6 kilowatt-hours per liter, yet ammonia does not emit hydrocarbons or CO2 when burned. Various organizations are studying ammonia as a low-carbon fuel. However, challenges remain. Igniting ammonia is more difficult than traditional fossil fuels, and it burns more slowly. A significant achievement was solving these combustion issues. This compound, formed from nitrogen and hydrogen, can be derived from renewable sources. Solar, wind, or hydroelectric power are examples. Its high energy density and lack of carbon dioxide emissions when burned make it an attractive alternative to fossil fuels. Igniting ammonia has always been more complex due to the higher flame temperatures of fossil fuels. This restricted its use as an alternative energy source, especially in passenger cars. However, GC overcame this obstacle by developing a new combustion system that ignites and burns ammonia efficiently and effectively. Technologies such as spark ignition and direct fuel injection were employed. These innovations improve combustion and reduce emissions, paving the way for ammonia in passenger vehicles. This could reduce greenhouse gas emissions and dependence on fossil fuels. Seung John, an engineer at GC, spoke about overcoming ammonia's slow burn rate. "We are excited about its potential for society and commercial use," he said. Ammonia serves combustion engines, fuel cells, or hybrid systems, depending on customer needs and preferences. Ammonia's ease of storage and transport, unlike hydrogen, positions Toyota as a forward-thinking investor in alternative fuels and electric vehicles. This includes the Mirai, which uses a hydrogen fuel cell. The company is also testing hydrogen engines in motorsports. Toyota's investment in GC demonstrates an interest in ammonia engines, potentially starting in China and expanding as the technology evolves. Despite challenges, ongoing improvements in ammonia engines and involvement from major companies indicate a cleaner, more sustainable future for transportation. The future of green vehicles. China leads the global market for electric vehicles, yet there remains a significant demand for cars powered by traditional combustion engines. However, the Chinese government is considering banning the sale of these traditional vehicles, inspired by measures adopted in California. Such a change would open doors to the adoption of ammonia-powered vehicles, representing a greener and more economical option for the Chinese populace. Ammonia cars could reduce China's need for imported oil and significantly improve the country's air quality. This would position China at the forefront of ammonia vehicle utilization, setting an example for the world. Alternatives like hydrogen, ammonia, and synthetic fuels could breathe new life into combustion engines. These promising fuels may become cheaper than fully electric vehicle technology in the future, offering an attractive and green option to a broader audience. They also address some convenience issues. Toyota, with a strong presence in the Chinese market, has already developed electric vehicles specific to the region. Yet, it continues to explore other technologies, such as ammonia engines, showing its commitment to catering to diverse consumer preferences. It will be interesting to see if this technology reaches the market on a large scale and globally. The potential inclusion of vehicles powered by alternative fuels, such as ammonia, in China, adds a fascinating dimension to the transition to more sustainable transportation methods. Ammonia cars could cut harmful emissions, reduce dependence on imported oil, and improve air quality. While GC and Toyota are advancing in this field, they are not pioneers. About a decade ago, the Korean Institute of Energy Research introduced the ANV, a car that used a mixture of 70%